Each year, Australia throws away about 8,000 tons of used household battery that end up in the landfill. They might have some toxic chemicals and metals that can leak from batteries, which contaminate the environment. Sodium hydroxide and potassium hydroxide are strong corrosive electrolytes, which are often used in the bottom battery. If the bottom battery cannot dispose properly, they might sink into the river, and the hazards of both of them for the environment are caused by the hydroxide ion. A high concentration in water will result in toxic effects for aquatic organisms. Also, the metals which in a normal battery are more toxicity, like manganese dioxide and mercury oxide. Those two all are toxicity metals, which can harmful to the environment and break the goal of sustainable development, which is life on land. In our prototype, we are trying to solve these problems and meet the sustainable goal. We use some juice from lemon and lime to replace harmful electrolytes, also use zinc, copper, and graphite to reduce the ecological footprint and emission to the environment.
Generally, our designs are similar with current batteries, so our designs still have anode, cathode, and electrolyte. Also, degradable material will be used to form a small container to contain electrolyte. Anode will donate electrons while reacting with electrolyte. Cathode will accept or accumulate electrons. The material of anode and cathode must have sufficient differences in their reactivity. When our design connects to electrical appliance, the electrons will transfer from anode to electrical appliance, then cathode, to produce electricity power. In this process, energy changes from chemical energy to electrical energy. Probably a small amount of heat energy will be produced as well, due to the internal resistance of our design. But the main differences between our design and current solutions are material. In order to reach two sustainable goals, we generate multiple solutions. Acidity solution from juice to replace strong base such as sodium hydroxide as electrolyte. We consider lemon juice or lime juice, as they are accessible, also shows lower pH value than other juice. So we think they might present better. For anode and cathode, we also have two options: zinc and copper or zinc and graphite. Unlike lithium calcium, zinc will be too reactive and the reaction is easier to control. Graphite costs less than copper, but both of them are commonly used in cathode. Compared with the current bottom battery, no mercury was used in our design, and also our electrolyte is more safer.
The first trial we are going to test with lemon juice and without any additive. We take 2 teaspoons of lemon juice and put into the container. Clip the two metals to the tester. Make sure they got the same surface area. Then record the result. In trial 2, we are going to add some salts in it. Take a quarter teaspoon salt. Mix well with lemon juice. Then record the result. We are going to add some vinegars in lemon juice. Take a quarter teaspoon of vinegar and mix well with lemon juice. Then record the results. We use the same method as previous, but we change the lemon juice to lime juice. We change our two metals to zinc and graphite. 2 teaspoons of lemon juice. Because graphite is relatively fragile, I use half of it, and then I try to match the surface area of zinc to the graphite. We change the lemon juice to the lime juice.
For our multiple solutions, we try to select one which can balance cost and produce higher voltage. Following video shows how we test our solution. Therefore, our test result shows lime juice as electrolyte, zinc and graphite as anode and cathode can present better results. Making two of our design in series can produce high enough voltage to light up LED or run a normal watch. Finally, we consider our design still can be better around the following aspect. Our voltage is not as stable as the current battery, also due to the insufficient technology and scientific knowledge. Minimize the size of our design. What kind of degradable material should be used? How to deal with hydrogen gas produced, except preserving them inside the battery still can be improved in the future.